Welcome to another Mount Holyoke College Psychology Statistics Hub tutorial. This is your lab director, Natasha, with another research question for you. Imagine Mount Holyoke Admissions is interested in how many hours students spend studying each day, so as better to inform their tour guides. They believe the number of hours studying may be different based on whether students are highly involved in extracurricular activities or not, and whether students live on or off campus. They also wonder if there is some combination of living on or off campus and being highly or less involved in activities that results in students studying different amounts of hours. What analysis could you use to answer this question? The Factorial ANOVA tests means of different levels of more than one independent variable on a dependent variable. You should run a Factorial ANOVA when you want to compare means of different levels and groups of more than one variable on a dependent variable. In this example, we're asking if the numbers of hours students study at Mount Holyoke is different based on whether students live on or off campus and whether they are highly involved or less involved in extracurricular activities or some combination of these groups. So to run a Factorial ANOVA in RStudio, the code for running the ANOVA is very similar to running the one-way ANOVA. The only thing that we change is to use an asterisk or a star symbol between the factors that you are interested in running. So remember, when we want to import the data file, that we want to make sure that the computer reads the factors as factors. So I'm going to upload So I'm uploading the stats practice data set, and our factors in this case are activities and on campus. So we'll want to go over to where it says activities in the data preview and change it to character. And we'll want to do the same for on campus. We'll want to change using the drop-down menu to make this as a character so that R will read these two variables as factors. Then we'll click import. And then we can use the code listed in the note above to run our ANOVA. So we'd write the following command. Again, we're going to save this as a model because we want to be able to take a summary of the model to view the output. So model goes into AOV, our dependent variable, so in this case, studying, the tilde sign, activities, which is our first factor, the asterisk or star, and then our second factor, which is called on campus, comma, data, and then we'll let it know that stats practice is the data set we're using. We'll hit enter, and then we're going to take the summary of the model. So here's our output. This tells us right away whether each main effect or the interaction are significant. So we can see, because it's marked with a star, the only significant main effect is with activities. And that is a significant main effect. So we know there's a difference in the amount of studying that students do, whether they're high involved or low involvement in extracurricular activities. We can see, because the p-value is above 0.05 for the main effect of campus, or on campus, the name of the variable, that there's no significant difference in hours of studying between students who live on campus or off campus. And then we can also see with our interaction right here between activities and on campus, this again is above 0.05, so that's not a significant difference. So we'll probably also want to report our descriptives. So we will go ahead and type in the code to get the means and standard deviations. So let's type in by the name of our data set, so stats practice, $ studying, comma, stats practice, $ activities, comma, mean. Then we can hit enter to get that output. We'll see that students, again, 0 was coded as students who were less involved. one was coded as students who are more involved. So this tells us that the mean number of hours studied is higher. So it's 3.7 for students who were considered low involvement in extracurricular activities. And for students who are considered high involved, again, that they studied less, they say 3.1 hours. So that tells us right there, now that we know that the main effect is significant, we can give the direction and say, again, those who are less involved studied more than those who are more involved. We can also get the standard deviation by hitting the up arrow and just changing mean to SD. And that gives us the standard deviation for each of those groups. We can also do this for, even though we know that it's not significant, if we're wanting to report the means, we can change by hitting the up button twice, change activities to on campus to give us the difference in means between people who lived on or off campus. So it tells us that those who lived off campus studied for 3.3 hours, those who studied on campus were 3.5. And then if we again hit the arrow button twice and change activities to the variable on campus, then it gives us a standard deviation so that we can report those. Again, this is not a significant difference, but we can still learn what the means and standard deviations were for that factor. So that's how we run Factorial ANOVA and an RStudio. And given this information, we can report back to the admissions office, again, that there's no difference between students who live on and off campus in regards to how long they study. There is a significant difference between those who are highly involved and less involved, and those who are highly involved study significantly less than those who are have low involvement in extracurricular activities. And also that there's no interaction between whether students live on or off campus, are highly or less involved in extracurricular activities, any combination of those. So remember, until next time, don't be mean, be above average.